Let's look at this physical footprint. Maintaining an on-premise Hadoop environment means managing heavy, heat-generating hardware day in and day out. Mapping capacity against demand, we track exponential data volume growth against static on-premise capacity. That widening gap is the scalability crisis zone. Inside, it fills with data bottlenecks, maintenance hours, and steep financial costs until progress completely stops. Faced with these limits, the typical enterprise reaction is to pack up and immediately migrate workloads to the cloud, hoping for infinite scale and a quick reduction in expenses. But our research partners at Royal Research have a clear warning about this approach. Migrating without a rigorous architectural plan doesn't solve your problems. It simply moves your existing inefficiencies to a more expensive location. You are facing a distinct trade-off. You must endure the heavy friction of careful architectural planning and massive data transfer upfront, in exchange for the long-term dynamic scalability of a managed cloud ecosystem. Clinging to legacy on-premise Hadoop drains your IT budget, capital that should be spent deploying modern data architectures instead of swapping out hard drives. The first real hurdle you hit is physical logistics. This flowchart maps the migration friction path, starting at infrastructure assessment. Notice the first major branch highlighted here, data transfer. Moving petabyte-scale Hadoop datasets over a standard internet connection forces you to confront the basic limits of network bandwidth. The math simply does not work in your favor. Attempting a standard network transfer results in severe latency across your entire organization, followed by unacceptable system downtime while the upload drags on. And time equals money. The longer that data takes to egress from your on-premise servers, the more you pay in bandwidth consumption and extended operational overlap. To bypass bandwidth limits, cloud providers offer physical solutions. This chart compares transfer times. On the left, the extreme duration to move a petabyte over standard internet. On the right, the rapid deployment achieved by shipping data transfer appliances directly to your data center. While those physical appliances are in transit, your business still needs to run. This forces organizations to adopt complex hybrid networks to bridge the gap and maintain continuity during the move. You have to plan for complex physical logistics. Expecting a fast, frictionless digital upload of petabyte-scale data will derail your timeline. Data transfer is a massive logistical project. It is the physical anchor that dictates the viability of your entire migration schedule. Once you figure out how to move the data, you have to decide where it will permanently live. Managed cloud ecosystems promise a frictionless environment where you can rapidly provision clusters and use seamless native tools without ever touching hardware. 3 competitors dominate this space. This matrix evaluates AWS EMR, Azure HD Insight, and GCP Dataproc based on native integrations and ecosystem support. But first, audit current on-premise applications. See what happens when a legacy app fails connecting to mismatched proprietary APIs. If your legacy applications do not perfectly align with the new proprietary cloud tools, you risk broken dependencies and complete system failure. If your organization is already heavily invested in the Amazon ecosystem, AWS EMR offers deep native integration that keeps your existing services tightly connected. If you rely heavily on open-source frameworks, Azure HD Insight provides broad, robust support to keep those specific workloads running smoothly. And if your priority is Apache and Spark jobs, GCP Dataproc delivers highly fast, cost-effective execution tailored exactly for those formats. Choosing an ecosystem that doesn't match your existing architecture leads to wasted engineering effort and vendor lock-in. It negates the exact agility you moved to the cloud to achieve. With the migration complete, the focus shifts to the daily financial reality of operating in the cloud. Many organizations attempt a lift and shift approach, moving legacy workloads directly into the cloud without modifying the underlying architecture. The immediate consequence is severe. Unoptimized workloads lead to skyrocketing, unpredictable cloud computing bills that quickly exceed your old on-premise maintenance costs. Controlling this requires active management. A cost control scorecard tracks 3 safeguards. First, right-sizing forces assessing exact needs before provisioning, shrinking a bloated server block to perfectly fit the workload. Second, auto-scaling seamlessly expands and contracts that block to match fluctuating data demand. Auto-scaling ensures you aren't paying for idle compute time. Your resources adjust based on immediate, real-world demand instead of relying on static limits. The final safeguard is utilizing reserved instances. By committing upfront to a specific capacity for your highly predictable workloads, you lock in significant cost savings. Cost efficiency does not automatically happen the moment you migrate. It requires continuous, active engineering investment to realize any financial return. We've traced the journey from an on-premise capacity crisis to the daily realities of cloud optimization. The cloud cannot magically fix poorly optimized data. Your success relies entirely on the preparation you do right now. For enterprise IT leaders, you have a strict mandate. This readiness matrix plots who is ready versus who should pause. The IT leader profile hits the ready column specifically when they commit to enforcing strict right-sizing policies. Your trade-off is time. Delaying the immediate gratification of a fast migration secures long-term predictable costs and a proven return on investment. For data architects, the matrix checks the ready column when you commit to refactoring legacy jobs for modern cloud-native containerization, like Kubernetes. You must survive a steep upfront learning curve and temporary operational disruption. The reward is highly resilient, modernized data pipelines. Ultimately, as Royal Research advises, the speed and success of your migration rely on one factor: how deeply your team understands its current data volume and legacy dependencies. Do not endure the massive friction of migration just to change physical locations. Migrate specifically to modernize.